Good morning. I am Ali from CSMA section. Today is my topic is about finite automata. Introduction to finite automata. The study of abstract computing devices or machines. Automation equal to an abstract computing device. Note: a device need not even be physical hardware. The term automata is derived from the Greek word which means self-acting. Automata is a plural. Automaton is a singular. Finite automata are used to in the text processing, compilers, and hardware designs. A finite state machine or a finite state automaton or a simply state machine is a mathematical model of computation. It is an abstract machine that can be in exactly one of a finite number of states at a given time. The FSM can change from one state to another in a response to some inputs. The change from one state to another state is called transition state. An FSM is defined by a list of its states, its initial state, and the inputs are that trigger each transitions. Finite automata examples. For example, on-off switch. As you can see in the picture here, the off is the starting state, and the between is push. The push is action state. Modeling recognition of word then. As we can see in the figure, the starting state, transition, intermediate state, final state. Definition: a state is a description of the status of system that is waiting to execute a transition. A transition is a set of actions to be executed when a condition is fulfilled or when an event is received, like a final state and initial state. The input tape. The input tape is divided into squares. Each square contains a single symbol from the input alphabet. The end square of each tape contains the end markers different from the symbol of first one. Options of end markers indicate the tape is of infinite length. The symbols between and end markers is the input string to be proceeded. Read and write head. The read and write head examines only one square at the time and can move on the square either to the left or the right. Finite control. The finite control can be considered as the control of the finite unit of an FA. A automaton always resides in a state. The reading head scans the input from the input tape and sends it to the finite control. In this finite control, it is decided to that the machine is in this state and getting this input, so it will go to this state. The state transition or relations are written in the finite control. Types of finite automata. The different types of finite automata are follows. The first one is deterministic finite automata, DFA. Non-deterministic finite automata, NFA. Non-deterministic finite automata with epsilon, MOS, NFA. E to NFA. Finite automata with output, Moore machine and Mealy machines. Finite automata representation. The finite automata can be represented in the three ways: graphical transition diagram, that is tabular transition diagram, mathematical transition functions. These are the three types we can represent the finite automata representation. And here it is a transition diagram. It is a directed Graph associated with vertices of the graph corresponding to the state of finite automata. As we can see in the figure, the zeros and ones are inputs. Q0 is the initial state, Q1 is the intermediate state, and Q2 is the final state. Like, and the transition table. It is basically a tabular representation of the transitions function that takes two arguments, a state and symbol, and returns a value to the next state, equal to q into epsilon. In the transition table, the following factors are considered. Rows corresponded to state, columns corresponded to the input, entries corresponded to the next state. The start state is marked with the accept state marked with start. And the transition function. The transition function is denoted by the two parameters are mentioned below are the passes to the transition function. First one current state, second one input symbol. These are the two parameters mentioned to pass the transition function. The transition functions returns a state which can be called as the next state, equal to current state, current input underscore symbol equal to next state. For example, what does a DFA do on reading an input string? This is a question. The input equal to a word W in sigma star epsilon star. Question: is W acceptable by DFA or not? The steps: start at the start state, which is called Q0. For every input symbol in the sequence W, do compute the next state from current state given the current input symbol W and the transition function. If after all the symbols in W are consumed, the current state is one of the accepting state F, then accept W, otherwise reject the W. This is about DFA and reading an input string. And here a simple example one. Build a DFA for the following language. L equal to, in the set W by W is a binary string that starts with a 0. Steps for building a DFA to recognize L. Epsilon equal to 0, 1 in the set, in the string. Decides on the states. Q. Designate start state and final state S. Decides on the transitions. Final state equal to as same as accepting states. Other states equal to same as non-accepting states. This is about it. And the language of a DFA is a DFA accepts strings W if there is a path from Q0 and to an accepting or final state that is labeled by W. And let us talk about how to use an NFA. Input a word W in epsilon star. Question: is W accepted by NFA? Steps: start at the start state Q0. For every input symbol in the sequence W, do determine all possible next states from the all current states given the current input symbol in W and the transition functions. If after all the symbols in W are consumed and if at least one of the current state is final state, then accept W, otherwise reject W. This is about how to use NFA.